So often we would like to do the same calculation over and over again, but maybe with different values for some of the identifiers. So in order to avoid having to write the program text over and over again, we introduce the concept of a function. So here is the function sqrx calculates x times x. So function is declared with the keyword fun, F-U-N, up until end. We have here first the header between braces, the name of the function sqr and the arguments. Here there's only one, x. And then the function calculates the expression x times x. So this is the function definition. So I feed this to the system. And now I can display the browse, and I do square of 10 here. Remember, function calls, like procedure calls, have the braces surrounding them. This displays 100. So square of 100 of 11 is 121. It also works for different kinds of numbers. 10.1 gives 102.01. So this lets me introduce two kinds of numbers in Oz, the exact numbers, which are integers, and the approximate numbers, which are called floating point numbers, which approximate real numbers. So these two sets of numbers in Oz are completely separate, and there's no mixing between the two, no automatic conversion. So the multiplication operation, when given an integer, will return an integer. When given a float, will return a float. So let me define now a function which does a little bit more. Here's a function sum digits, which takes an integer n, which is a 3-digit number, and it returns the sum of the 3 digits of n. So in order to do that, I have to get the 3 digits of n. So for example, this is done using the functions div and mod. This is division and modulo, which work for integers. So for example, I can do n mod 10. This is the lower digit. And then I can do n div 10. This divides the number by 10. And if I do mod 10, this will give me the second digit. And then I can do n div 100 mod 10. This gives me the upper digit of the 3-digit number. So this expression is a bigger one, and I don't want to write it over and over again when I calculate sum digits. So for example, I can do sum digits of 999, and this returns 27. Sum digits of 888 returns 24. So the sum of the 3 digits. Notice I've here introduced the functions modulo, which takes 2 integers, calculates their integer modulo operation, and div, which calculates their integer division operation with no remainder. And so there is another function called the division real floating point division to complete the set. So for example, 10.01 divided by 3.2, which is 3.1281. So notice I have here floating point division, I have here integer division. The multiplication here works for both integers and floats. And then there's an operation which exists only for the integers, which is modulo. So recapitulating, we would like to execute the same code many times, each time with different values for some of the identifiers. So to do that, we define a function. So function is just a shortcut for program code to execute, just like variables are shortcuts for values. And in fact, we can be more precise and say that functions are just another kind of value in memory, which is what we'll see later. The function here that we've declared sqr, square, returns a square of its input, so it's between the fun and end keywords. It has a header with braces, which looks just like the call, and then a body, which is the expression that is executed. So the fun keyword identifies the function, and the identifier sqr will refer to a variable in memory that is bound to the function. So talking about numbers, there's two kinds of numbers in Oz. There's exact numbers and approximate numbers. So all calculations with exact numbers are exact. All calculations with approximate numbers are approximate. So exact numbers in Oz are integers. Approximate numbers in Oz are called floating point numbers. So integers are exact up to 19-digit precision. This is corresponding to 64 bits. And floats are approximations of real numbers, and they have up to 15-digit precision. So one important point is that there is never any automatic conversion. So the exact and the approximate worlds are kept separate deliberately. And if you want to go from one to the other, you have to call functions that make the transition. Int to float, which takes an integer and returns a float, which is of the same value, and float to int, which takes an integer that approximates the floating point that you give it. So the design principle is don't mix incompatible concepts. The exact world and the approximate world have different ways of reasoning. In the approximate world, you will have rounding error and other kinds of errors. In the exact world, normally you will not have errors, so you are going to keep them separate. So we've defined then the function SUMDigits, which calculates the sum of the digits in the base 10 representation of a 3-digit positive integer. So this is defined as follows. This uses the mod and div, modulo and division integer functions. There is also another function, the slash, which is a floating point division, takes 2 floats and returns a float. And finally, the multiplication, which is the asterisk, is a function that works for both floats and ints. Give it to floats, it returns a float, and give it to ints, it returns an int.